All right, let's talk about one of the biggest, most fascinating puzzles in all of AI. It's called generalization. And you can think of it as the secret sauce, right? It's what separates a machine that's just, memorizing things from one that actually understands and can think in a way that feels, well, truly intelligent.
So it all boils down to this one question. Think about it. You can train an AI on, say, 1,000,000 photos of cats. Easy enough. But how? How does it learn to spot a cat in a brand new picture one it has never seen before? This is so much more than just memory. It's about real, genuine learning. And honestly, cracking this is the challenge if we're ever going to build truly smart AI.
Okay, so let's really dig into this generalization puzzle. It's all about this massive leap, right? The jump from just memorizing to actually understanding. So here's the textbook definition, but let's make it simple. Generalization is just the AI's ability to deal with new stuff it's never seen before. The analogy I love is a student. You have the student who just memorizes flashcards. Change the question slightly and they're lost. But then you have the student who gets the concept. They can answer any question you throw at them. That's what we want from our AI. That's the goal.
Now, for the longest time, for decades, researchers really only had one main way of tackling this problem. And look, this approach took us a really, really long way. But it's not the whole story. The old way was all about what we could call learning from the crowd.
And that big idea is known as statistical learning theory. The concept is actually pretty straightforward. It says, hey, if you want to understand a new problem, just go look at a huge pile of similar problems and find the patterns. It's kind of like trying to understand one specific tree by just looking at the average height, width, and leaf color of the entire forest.
And a really important paper on this topic just nails it. The authors say the old way looks at a set of problem instances via statistics. What does that really mean? It means it's all about the group, the average, the big picture, not the tiny, unique details of any one individual thing.
But you can probably see the problem here, right? If you only look at the average of the crowd, you're going to miss what makes each individual special. And that brings us to a huge question. What if there's a better way? What if we didn't have to study the whole forest to understand a single tree? And that is what brings us to this really cool new perspective. It's called analytical learning theory. And I want to be clear, this isn't just some small update. No, this is a complete, fundamental rethink of how we can teach machines to generalize. So what's the big deal? Well, the most important difference is that this new theory basically takes the old statistical rulebook and just throws it out the window. It says an AI doesn't need to make a bunch of assumptions about the whole giant dataset. It's a totally fresh start.
And this table really breaks down that shift. On one side, you've got the old statistical theory, which looks at a set of problems. It's all about statistics. It sees the forest. On the other side, we have the new analytical theory. It looks at each problem, one by one, and instead of stats, it uses something called measure theory, which is, a fancy math way of getting really precise. So instead of looking at the forest, it's like we're analyzing the DNA of a single tree.
Okay, so a new theory is cool and all, but let's be real. The big question is, does it actually work? Can you take this elegant idea and turn it into actual code that improves AI in the real world? That's the real test, right?
And yep, that's exactly what the researchers did. They took this new theory and built a practical tool from it, something called a regularization method. All that means is it's a technique to stop the AI from just memorizing the training data, to prevent it from cheating. Then they put it to the test on actual deep learning models to see if it really made a difference. And the results? Well, they were pretty awesome. As you can see here on standard vision tasks, this new method from the analytical theory just flat out performed better than the old ways. So the theory wasn't just a cool idea on paper, it actually worked. It was more effective. And listen, we're not talking about some simple toy problems here. They tested this on super well-known, notoriously difficult datasets like SciFAR 10, SciFAR 100, and the Street View House Numbers dataset. In the world of AI, these are like the Olympics. So proving your method works on these, yeah, that's a huge deal. So, okay, a new theory leads to a better result. That's great. But this is where things get really exciting, because the implications go way beyond just one technical paper. Let's zoom out and think about what this means for the future of AI. Because this idea, this shift towards analyzing individual problems instead of the whole crowd, it's going to have ripple effects across so many areas of AI.
We're talking about a better foundation for deep learning itself, for how models learn to represent information. And it even points the way towards some really futuristic stuff.
And that brings us to maybe the most mind-blowing implication of all, something called one-shot learning. This is basically the holy grail for AI researchers. It's the dream of getting an AI to learn a new thing from just one single example, the way a little kid can. And because this new analytical theory is all about focusing on individual things, it gives us a brand new, powerful roadmap for actually getting there.
So let's just leave it there with one final idea for you to chew on. If we can get an AI to learn from just one single example, if it can really grasp the essence of something from just one look, what happens next? What does that even make possible? What kind of intelligence are we really on the verge of creating here? It's pretty profound when you think about it.